All right, friends, here we are. This is question number 5 from the 2019 BC exam. So this is a calculator inactive question. I want to keep that in mind as we go through this problem. Totally calculator inactive. All right. Consider the family of functions f of x equals 1 over x squared minus 2x plus k, where k is a constant. Okay. A, find the value of k for k greater than 0 such that the slope of the line tangent to the graph of f at x equals 0 is equal to 6. Okay, so what is going on here? We've got some function f of x that involves k. K, you may remember, we call a parameter, meaning that it's going to change. It's not your variable necessarily, but it is a parameter. It's a constant, but we're going to be given different values of the constant that we're going to work with here. Find the value of k for k greater than 0. Let's keep that in mind. When they give you a domain restriction, you want to make sure that you pay attention, such that the slope of the line tangent to the graph of f at x equals 0 equals 6. Slope of the line tangent to the graph, well, we know that means the derivative. What I want is for f prime of 0 to be equal to 6. Well, what we know is that f of x is this 1 over x squared minus 2x plus k, where k is a parameter, so k is a constant. I need f prime of 0 to equal 6, so I'm going to start off by finding f prime of x, not f prime of 0, f prime of x. So f prime, I'm going to use my quotient rule. So low x squared minus 2x plus k, d high times the derivative of 1 is 0. I bet a lot of you already knew that. Minus high, the 1, times the derivative of the bottom, 2x minus 2, plus the derivative of k is 0, all over x squared minus 2x plus k, the whole quantity squared. I can simplify this, and I'm going to get that negative 2x plus 2 over x squared minus 2x plus k squared. Now keep in mind that's f prime of x. What I need is for f prime of 0 to equal 6. Well, f prime of 0, everywhere you see an x, replace 0. Negative 2 times 0 plus 2 is 2. In the denominator, 0 squared is 0, minus 2 times 0 is 0, plus k, and that gets squared. 2 over k squared is equal to 6. I can multiply both sides by k squared if I'd like to get that 2 is equal to 6k squared. That means that 2 over 6, or 1/3, equals k squared, and then k is plus or minus the square root of 1/3. Now, if you write k is equal to plus or minus square root of 1/3, you've forgotten about the domain restriction. The only acceptable answer is going to be k equals the square root of 1/3. Of course, you could write that as 1 over the square root of 3, or you could rationalize the denominator, multiply top and bottom by square root of 3, and you'll get that. Any of these answers here is considered numerically equivalent, and so they all get the point. Let's see, the way they awarded points here was 1 point, what did it say? 1 point for the denominator of f prime of x. Huh, interesting. I've never seen something so specific. So it looks like they said if you have this part correct, even if maybe you made some calculations in the numerator, you made some errors in the numerator, as long as this part is correct, you get a point. I've never seen that before. 1 point for having the whole general form for f prime of x correct. So basically they're awarding 2 points, but they're being very specific. I think I like that. And then the third point for saying k is equal to square root of 1/3. So that is a grand total of 3 points. I would expect most calculus BC students to be able to do that quickly and accurately. Let's move on to part B. Part B, for k equals -8, find the value of the integral from 0 to 1. So in part B, k is -8, which means now that f of x is 1 over x squared minus 2x, k is -8, and I need to evaluate my integral 1 over x squared minus 2x minus 8. Now you can try a whole lot of different things here. You could try substitution. I'm going to tell you that's not going to work. You might think it's an ln, right? Because you're seeing the 1 over stuff. No. If the denominator was linear, then 1 over something that's linear, I would absolutely think about an ln. What I want to think about here is partial fraction decomposition. I know it's been a while since we studied that unit on advanced integration techniques, but that is very legal stuff here. Remember, the goal is to rewrite your fraction as 2 or more smaller fractions, easier to integrate, easier to work with fractions. So the goal here is to figure out how do you go about rewriting this 1 over x squared minus 2x minus 8 as different fractions. The way that you're going to start is you're going to factor. X squared minus 2x minus 8 factors as x minus 4 times x plus 2. So that means now I'm going to look to rewrite this fraction as a fraction that has x minus 4 in the denominator and a fraction that has x plus 2 in the denominator. My denominators are linear, so my numerators will be constants. Maybe they're the same constants, maybe they're different. To solve this equation, I'm going to multiply everything through by that common denominator again. That changes the equation to 1 equals a times x plus 2 plus b times x minus 4. To solve this equation, you're going to evaluate the equation at different values of x. If I let x equal 4, then I get 1 equals a times 6 plus b times 0, so that means that a is 1/6. Another easy value to select, because it'll make x plus 2 equal to 0, is x equals -2. And the equation then becomes 1 equals a times 0 plus b times -6. So b is -1/6. That means now that I can rewrite my fraction as 1/6 over x minus 4 plus a -1/6 over x plus 2. So I can go to my integral, and rather than saying the integral from 0 to 1 of this fraction, I'm going to say it's the integral from 0 to 1 of 1/6 over x minus 4 plus a -1/6 x plus 2. Integrate that with respect to x. And because my fractions now are linear in the denominator, these should be able to integrate. These should be easy for me to integrate. The integral of 1/6 over x minus 4 is 1/6 the natural log of x minus 4, plus the integral of -1/6 over x plus 2 is -1/6 the natural log of the absolute value of x plus 2. I'm going to take that whole expression and evaluate from 0 to 1. What that means is I'm going to plug in 1 everywhere I see an x. 1/6 the natural log of 1 minus 4 is -3. The absolute value of -3 is 3. Minus 1/6 the natural log of, plug in 1 plus 2 is 3. So 1/6 the natural log of 3 minus 1/6 the natural log of 3. All of that minus, plug in the 0, 1/6 the natural log of 0 minus 4 is -4. Absolute value of -4 is 4. Minus 1/6 the natural log of 2. Now, these are all numbers. There is absolutely no need for you to waste your precious time simplifying. If you do simplify, well, 1/6 natural log of 3 minus 1/6 natural log of 3 is 0. And now I've got this expression here, and my advice is stay away from it. Don't do anything. If you do, though, be careful. You've got the negative outside. 1/6 natural log of 4 minus 6 natural log of 2 can factor out the 6th and leave natural log of 4 minus natural log of 2. A log minus a log is the same as saying the log of the quotient. So natural log of 4 over 2 and the natural log of 4 over 2 is the same as saying negative 1/6 natural log of 2. I want you to stop here after you've done the evaluation. Everything that you did afterwards is unnecessary. You're using up time and you are potentially going to make a mistake here. So they awarded 1 point for the partial fraction decomposition, 1 point for the antiderivative, so like this part here, before you do the integrating, but when you've rewritten as two different fractions, is 1 point. Correctly finding your antiderivatives is a 2nd point, and then simplifying is a 3rd point. You earn that point as soon as you did the evaluation. There's no need to simplify. It's a grand total of 3 points. Nice. A little bit trickier. Definitely calculus BC territory here. This is not the work that you'd be expected to do in the AB exam. Let's go one step further. Let's look at part C. Okay. For part C, we're told for k equals 1, find the value of the integral from 0 to 2 f of x, or show that it diverges. Okay, that diverges would mean that my integral has a value of positive infinity or negative infinity, or it's bouncing all over the place. That guy right there makes me start to think, be careful, this could be an improper integral. Well, let's see what's going on. K is equal to 1. We're doing an integral from 0 to 2 of 1 over x squared minus 2x plus 1, integrating with respect to x. Now, at first you might say, that doesn't look like a problem. It looks like another partial fraction decomposition. Maybe. Try factoring x squared minus 2x plus 1, and you're going to get x minus 1 times x minus 1. These are repeated factors. That means I can rewrite my problem as the integral from 0 to 2, 1 over x minus 1, the whole thing squared with respect to x. And you might be thinking, what's the problem? The problem is that your denominator, if x equals 1, x minus 1 squared equals 0, which means that 1 over x minus 1 squared is undefined. That means you've got an improper integral. And if you're working with an improper integral, the only correct way to do this is going to be to rewrite this problem as, in this case, two different definite integrals. We're going to evaluate from 0 to 1, 1 over x minus 1 squared dx, and we're going to add on to that the integral from 1 to 2, 1 over x minus 1 squared dx. The problem happens at x equals 1. So I cannot do an integral from 0 to 1 of 1 over x minus 1 squared dx. Instead, we're going to have to do that thing where you say, let me change the problem and say, let me integrate 1 over x minus 1 squared with respect to x from 0 to b, and take the limit as b approaches 1. We're approaching 1 from the left, numbers smaller than 1. And then we're going to add on to this another integral, the integral 1 over x minus 1 squared dx. And now I'm going to do something different, like c from c to 2, and I'm going to take the limit as x approaches c, I'm sorry, not as x approaches c, as c approaches 1 from the right. Numbers a little bit bigger than 1. From a number a little bit bigger than 1 to 2, this is a proper integral. From a number 0 to a number less than 1, just a little less than 1, is a proper integral. We're going to evaluate both of these. I'm going to focus on just the first integral, and you'll see why in just a bit. If I'm going to evaluate this limit as b approaches 1 from the left, first of all, let me rewrite this as x minus 1 to the negative 2 power. I've got a linear expression raised to a power. The rule is add 1 to the power, divide by the new power. That's my integral. I'm going to evaluate from 0 to b, and then I'm going to take the limit as b approaches 1 from the left. Well, let's see. That means limit as b approaches 1 from the left. Because I'm going to have to evaluate, I'm going to read this. X minus 1 to the negative 1 power says go back into the denominator. I'm going to have 1 over negative 1 to the x minus 1. We're going to evaluate from 0 to b. If I take the limit as b approaches 1 from the left, plug in the b, 1 over negative 1 times b minus 1. Plus, no, I'm sorry, minus 1 over negative 1 to the 0 minus 1. Well, what happens? As b gets close to 1 from the left, think about numbers like 0.9, 0.99, 0.999. Sorry, I was off the page for a little bit there. B is getting closer to 1 from the left. I'm not equal to 1, but I am close to 1. 0.9, 0.99, 0.99999. That minus 1 is going to give me some number very close to 0, but negative. Times this negative makes it positive. The denominator gets close to 0. The numerator is 1. That means that this fraction is going to approach infinity. This fraction over here is 0 minus 1. Well, that's negative 1. Times negative 1 is 1. 1 divided by 1 is 1. What I'm getting is infinity minus 1. What I know is that this part here diverges. If the first part of my integral that I'm trying to evaluate diverges, it doesn't matter what the next part does. If this part diverges, that takes control. The whole limit, the whole integral is going to diverge. So my conclusion would be, therefore, the integral from 0 to 2 of 1 over x squared minus 2x plus 1 with respect to x diverges. I think this is a really tough question. It's a good question. It is a solid question. This is one that I think maybe a lot of folks are not going to earn lots of points. They awarded 1 point for, it says 1 point for improper integral. I'm not exactly sure what that means. That might mean rewriting the improper integral as proper integrals, maybe. Not sure. 1 point for finding the antiderivative. So when we did this work in here, that earned us a point. And then finally, answer with reason. Well, here's the answer, and all of this up here is the reason. That would give us the grand total of the 3 points that we were after. I think A and B would be high scoring questions for most of you. I think part C, probably not so much. But that's the end of question 5. Hope you found that helpful. 2 down, 4 to go.